In this video, we're going to talk about multiplicity of a zero. When we're talking about multiplicity, what we're looking at in particular is the exponent that goes with the factors. So we are actually going to be concentrating very closely at the behavior at the x-axis, where the zeros are. So before I get ahead of myself, let's go ahead and just look at the type of functions that I have here. This function is linear, and the actual equation is y is equal to negative x minus 4. So if I were to graph that, it would graph like this. This type of function that gives me a parabola is a quadratic, and the actual equation is y is equal to x squared minus 6x plus 9. But I'm also going to write this in vertex form, or factored form, which is y is equal to x minus 3 squared. And there's a reason why I'm writing it like that. The last function is cubic. And if I were to write out the full equation in standard form, it would be y is equal to x cubed plus 6x squared plus 12x plus 8. But if I were to write it in factored form, and which also happens to be vertex form, it would be x plus 2 cubed. Okay. So what I have written in red is going to actually be helpful when we look at this. So let's talk about the degree. What degree does a linear function have? Well, we're looking at degrees. The highest degree is 1. So it's a degree of 1. What's the behavior at the x-axis? If we could zoom in really close and just look just at this part in yellow, we can see that it goes straight through. So the multiplicity of the function at the 0, where the 0 is x is negative 4, so I'm going to write down at the 0, where x is negative 4, we have a multiplicity of 1. Okay? That's just telling us what degree we will have. It's going to match there. Okay, so let's go ahead and let's look at our quadratic. So we can see our quadratic has a degree of 2. So it has a degree of 2. But what's the behavior of this particular function right in that yellow region of our 0? It touches. It simply touches. It comes down, touches, and goes back up. It doesn't go through. So what's the multiplicity of a quadratic? Well, we see something that's like a quadratic. It has a degree of 2. So let's just write what the 0 is there. That 0 there is x is 3. So at x equals 3, that's where our 0 is. We're looking right here. We have a multiplicity of 2. So when we come here and we look at it written in factored form or vertex form, we can see that at our 0 for this, where x, the factor x minus 3, gives us a 0 at x is 3, the exponent is 2. So that's our multiplicity. So when we look at our last one, which is cubic, our degree is 3, which we get right there. Notice in both forms, standard form and in vertex form, we still have the same exponent. The degree is 3. Well, what's the behavior at that x-axis? It goes through, but it also has a little bit of a curve or a whoosh. So we're going to say that it goes through with a whoosh, like a little Nike thing. So this degree, when it looks like this, at our x-axis, we have a multiplicity of 3. So what is our 0 here? Our 0 happens to be where x is -2, so at x equals -2, we have a multiplicity of 3. Okay, so what we're going to do is we're going to take this idea of what's happening right on the x-axis, and we're going to apply it to something that looks quite messy. Okay, so this here is not any one particular function. I'm going to tell you it's an even function, probably of degree 4. And so we can actually figure out exactly what this equation is, although I'll have to give you the answer to the coefficient because I had to do something to coefficient so it would graph like that. So what we're going to do is we're going to focus at our zeros. We're going to focus at our 0 here, at our 0 here, and at our 0 here. So the first thing we're going to do is we're going to write down what the 0 is. So right here, my 0 is x equals -4. Right here, my 0 is x equals -1. And right here, my 0 is x equals 5. So I simply just wrote down what the zeros were at each place. Let's write the zeros as factors. So to write this as a factor, remember we're going to make this equal 0. So what would I do? I would simply add 4 to both sides of that equal sign. So one factor is x plus 4. Same thing happens here. I would add 1 to both sides of that equal sign. So my other factor would be x plus 1. And then here I would subtract 5 from each side, and I get x minus 5. Well, this is not accurate as far as our equation goes because each of our factors has to have an exponent, a certain multiplicity. So when I look at my 0 that goes along with this factor, right here at my x-axis, this looks like a straight line. This looks like a line, and it's going straight through. So this part of my function right here looks like this. So that means that this factor has a multiplicity of 1. So that's a multiplicity for 4. So at x equals -4, I have a multiplicity of 1. That's the exponent that goes with that factor. When I look here, I see it not only goes through, but it has a whoosh, just right here at the yellow. I really don't care what's happening anywhere else on that function, just at what I've highlighted with the yellow. Well, if I remember, that looks like a cubic. My cubic was right here. This is what my cubic looks like. Look at my cubic had that same behavior. So that means for this 0, on the factor, it has an exponent of 3. So that means at x equals -1, I have a multiplicity of 3. Okay, so let's look at our last one here. By the way, what you need to understand is that this continues up somewhere and over like that. and I have an arrow here and an arrow here. So there's not two separate functions, it's one function. We just can't see the top part here. So what is the multiplicity here? Well, this part right here just touches and bounces up. This part right here looks like a parabola. What's the multiplicity of a parabola? The multiplicity of a parabola is 2. So that means here I'm going to have an exponent of 2. So that means at x equals 5, there is a multiplicity of 2. So in factored form, this is what would graph this equation. Something's very similar. So it would be x plus 4. I could write the power of 1, but I don't need to. X plus 1 cubed and x minus 5 squared. Now I'm not going to multiply all that out because now that I look at it, I'm like, wow, that's a lot of multiplication. But I can tell you what degree function this is, and I can tell you whether or not it's going to be positive or negative. So when I look here, if I count up my degrees, I have 1, 3, and 2. So my degree function is 1 plus 3 plus 2, which equals 6. So this is a 6th degree polynomial, and because both ends are in the same direction, that also helps me with this. This is even. 6 is even. So this polynomial is also even. They match, so that's good. And because my ends are going up, so both ends go up, that tells me it's even. That means it's a positive polynomial. So if you were to graph this in your calculator, you're going to get something very similar. When I went ahead and I made this function, I actually had a coefficient in the front. So actually, in order for it to get, so that you could see it nicely, I actually had a coefficient of 1 over 70 right in the front. So you can go ahead and put this in your calculator, and you'll see that this is going to graph this function right here. So that's multiplicity. Multiplicity in review is you look at what's happening, behavior at the zeros. If it looks like a line, it has a multiplicity of 1. If it looks like it's cubic, it has a multiplicity of 3. If it looks like it's just touching like a quadratic, it has a multiplicity of 2. And the multiplicity is the exponents that go with each of the factors that correspond with the zeros.